This video is Trig Notes 5.2. We're dealing with logs. The first thing we need to understand is what is a log. A log is just a way that we can write a problem where it will involve an exponent. Now what we're used to seeing is this, something in exponential form. 2 raised to some power or 2 raised to some exponent of 4 is equal to 16. Well, we're going to be looking at log form now. Log base 2 of 16 equals 4. And we're going to have to deal with this and figure out how does this mean the same thing as 2 to the 4th power equals 16. Well, as you look at the log here, this, as we read it, we said log base 2, so 2 is the base. So this smaller number that we write that's sort of subscripted here is always the base. Whatever our log is equal to, in this case 4, is always the exponent. And the other number that you have left over was really your answer in exponential form. 2 raised to some power of 4, or 2 raised to the 4th power, gives you 16. We're going to be looking at in this video going back and forth between writing something in exponential form, going to log form, or if you already have it in log form, going to exponential form. And so let's look at some examples of how we would do that. So if we have it in exponential form, 2 raised to the 3rd power equals 8, again we're used to seeing this form. How would I write that in log form? Well, first of all, remember that 2 is our base, and 3 is our exponent. Okay, and 8 is our answer. So 2 raised to the 3rd power is 8. So when I'm looking at this, again, all we're really asking for when it's in log form, log is a request for an exponent on the base of 2 that will result in 8. So in other words, I want to know what the exponent is. Okay, and keep this in mind. Log will always be equal to the exponent. Okay, log is always equal to whatever the exponent is. So the way we should set this up is say the log of our base 2, so we make a 2 as a subscript, of 8 is equal to 3. 2 to the 3rd power equals 8. So our base goes here. Our log is equal to the exponent. The exponent was 3, so it goes here. And then the only number we've left over is 8. Log base 2 of 8 is equal to 3. And again, this is important to remember that a log is equal to the exponent. So this log equals the exponent of 3. 3 was the exponent over here. It's equal to 3 over here. Looking at the next problem, 5 squared is equal to 25. 5 is my base, and 2 is my exponent. So I know that this problem has to equal 2, and then I would take log of my base, so make 5 as a subscript, and then 25. So log base 5 of 25 is 2. Okay, well what if we have a variable in the problem now? Still, we can write this the same way. 10 is my base, x is my exponent, so log of my base 10, log base 10 of 7 equals my exponent of x. So we've taken 3 examples in exponential form and we wrote them in log form. Let's work backwards now. We're given log form. Let's write it in exponential form. Again, it's helpful to identify what you're working with. 4 is the base, and 3 is the exponent. Remember, my log is always equal to the exponent. So this is really asking us to take our base, raise it to our exponent, and it should equal 64. 4 to the 3rd power does equal 64. Over here, my base is 5, and my exponent is x. So this one is saying 5 raised to some power has to give me 125. So now let's take a look at a problem where we're asked to figure out what this log is equal to. It says log base 3 of 9 equals what? We're trying to figure out what that what is. So let's write this in exponential form. Remember that this problem is saying log is a request for an exponent on our base of 3 that will give us a 9 as our answer. So in other words, 3 raised to some power we don't know equals 9. Well, this is a pretty basic one. We know that 3 squared is the same as 9, so my answer here would be 2 because that's my exponent. Looking at the next one, it's asking log base 4 of 2 is equal to what? We don't know. So writing in an exponential form, 4 raised to some power has to be equal to 2. Well, looking at this problem here, The best way to solve this is to make my bases be the same. So I know that since this is a base of 2 already, I could write 4 as 2 squared. So I could say 2 squared raised to some power x has to be equal to 2 raised to the first power. Working with my laws of exponents here, when I go from a power to a power, we multiply these together. So if I multiply this, I really get 2 raised to the 2x equals 2 to the first. Now I can set my exponents equal to each other. 2x equals 1. Solving this for x, I'd get 1/2. So this was a request for an exponent on 4. So 4 raised to what power would give me a 2 as the answer. 4 raised to the 1/2 power gives me 2. Next problem says log base 5 of 1 equals what? So 5 raised to some power has to give me 1. Well, right away I know I'm not going to be able to make my bases be the same. This is a base of 5 and this is a base of 1. But I do know that there's a special rule out there. It's called the 0 power rule. It says when you raise anything to the 0 power, you get 1. So the 0 power rule tells me that my exponent here should be 1. 5 to the 0 power is actually 1, so my answer is 0. So keep in mind the 0 power rule means that your answer, anything raised to the 0 power, would result in a 1. Again, this was a problem that asked me to take 5, raise it to some power, and get 1. 5 raised to the 0 power gives me 1. This one says log base 5 of 5 equals what? So 5 raised to some power has to give me 5. So 5 raised to some power gives me 5 would mean that this has to be a 1. Because 5 to the first power is going to give me 5. Over here, this one is saying the base of 5, so 5 raised to some power, has to give me 5 to the third. Well, since your bases are already the same, both base of 5, you know that the x has to be equal to 3. You just set your exponents equal to each other, you already get your answer of 3. So this one is saying 5 raised to what power will give me 5 thirds. Or not 5 thirds, 5 raised to the third. Okay, looking at this next problem, this time I have log base 2 of x is equal to log base 2 of 5. So in other words, what I'm really dealing with here is 2 raised to some power here. 2 raised to some power, I don't know, has to be the same as 2 raised to the 5th power. In other words, when you have logs like this, where a log of base 2 of some number is equal to log base 2 of some other number, then you can just get rid of these logs. And you would see here, since they're the same base, you can set these equal to each other. And you would end up with 5 as the answer. So we don't really need to fill this one out for that because it was a little bit different. So we'll just cross that off. Look at this next one. This one doesn't have a base. Notice this just says log of 1,000. When there is no base, we're assumed that it's base 10. And this is how your calculator works. Your calculator works in base 10. Okay? So if you were just to type in your calculator log of 1,000, you would end up giving you, your calculator would give you a 3. Well, how did they get that? What they did is they wrote this as log base 10 of 1,000. So they're saying 10 raised to some power has to be 1,000. Well, 10 raised to the third power is going to give me 1,000. So that's how they got 3. It's really important to understand that when you have no base here, that your base is actually a 10 when you have a log. Okay? Because we're going to take a look at now another log, which is called the natural log. So in our calculator, it's the ln. And in the calculator, there is another log, which is what we've been working with, which is just the normal base 10 log. So you have to understand when you use the log button like this or the ln button. So if you saw something like this, log of x, what you're really doing is you're doing log base 10 of x. When you do the natural log of x, the natural log has a base of e. So remember, e we said was equal to about 2.718. So this problem is really saying the natural log of e raised to, the natural log base e of x. So depending on which log you're using will depend on what your base is. When it's a regular log, it's base 10. When it is the natural log, it's base e. So let's keep that in mind when we look at our next examples. So here we have a problem that asks you for the natural log of 1. So before we just type this in our calculator and get the answer, let's write it in exponential form. Remember, natural log has a base of e. So we're saying e raised to some power, and I wrote it as 1, but I meant to say, I said some power, but I wrote it as 1. So e raised to some power, because we want to know what this is equal to. Okay, so e, our base e, raised to some power, I called it x, has to be equal to 1. So the only way that I'm going to get that, again, is remembering the 0 power rule, that when I raise anything to the 0 power, I get 1. So this would have to be e raised to the 0 power would get me 1. So my answer is 0. Again, I was looking for an exponent on e that would result in 1. E raised to what power gives me 1? Again, that would be 0. Here, it's saying the natural log of e is equal to what? We're trying to figure out what it's equal to. Okay? So, writing in an exponential form, you have a base of e. E raised to some power, because I don't know what it's equal to, will be equal to e. Well, the exponent with e is an imaginary 1. So because our bases are both e's, we can set our exponents equal. We get 1. Whoops. So our answer here is really 1. We were looking for a exponent on e raised to some power that would give me e as the result. So writing this one in exponential form, again, put our base of e down here. This is saying e raised to some power, we don't know, so we'll call that power x, has to be equal to e to the 4th. So I'm looking for an exponent on e that will result in e to the 4th. So this one, again, bases are the same, so x would have to equal 4. Now here is, this problem gets a little bit more difficult because now I'm taking the natural log of 7. So algebraically, we would say e raised to some power has to equal 7. Well, 2.718 raised to what power gives me 7? I don't know, and I can't figure that out on my own. I'm going to need my calculator to do this one for me. So in my calculator, hit the LN button and then 7, and your calculator gives you 1.95 if we round it. So we can say our answer is approximately 1.95. So again, I'm looking for an exponent on e that's going to give me 7, and I just can't think of that on my own because it's not a nice number to deal with. So keeping that in mind for the next example here, the natural log of 25. So again, the natural log has a base of e. E raised to some power has to give me 25. Again, 2.718 raised to what power gives me 25? I'm not sure, so let's use our calculator. And in our calculator, we'll type in the natural log of 25, and the calculator will give you the answer of 3.22 if you round it. So we could say this is approximately 3.22. That 2.718 raised to the 3.22 power is roughly 25. So again, we're looking for e raised to some power to give me 25.